A very good morning to our lecturer, Encik Ahmad Faris and Lee Bao-Yi. In this video, I will rerun Lab 4, Interactive Usage of Linked Libraries using Microsoft Visual Studio 2010. In this Lab 4, there are total 3 questions. Each question will require me to write a full assembly code program to solve the problems given, using the concept of loop, if-else condition, and also the other basic concepts learned before, such as multiplication. Question 1. A program will need us to solve the problem to calculate the perimeter for both hexagons with the sides input by the user, and then the perimeter for the both hexagons will be calculated using the loop concept, and finally the two parameters will be summed up and put into the variable of total perimeter. After debugging, an execution window will pop up. Me as a user will key in the side value for both hexagon 1 and hexagon 2. The hexagon value, the side value for hexagon 1 will be 5. For hexagon 2 will be 4. And after this, the lines showing the parameter for both hexagons with side that I've entered will be calculated using the loop concept, and then the total parameter will be shown also inside integer. In the data segment, all the data and the variable are declared by referring to the output desired in the lab sheet. For example, string 1 will be declared as the container to store the string, enter a side value for hexagon 1, and side hex 1 will be a variable declared to store the input value from the user. And the parameter hexagon 1, parameter underscore hexagon 2, and total parameter are declared as these are the variables assigned by the questions to store the values. First, we'll move the address of string 1 to EDX register. Then it will display the string of string 1 by the instruction call string. After this, it will require us to enter the side value 5 as a side value. And after this, the EAX value which input by the user will be stored to side hex 1 variable. And here, EAX and side hex 1 will have the same value of 5. Next, we'll need the user to enter the side value for hexagon 2. Same goes to the process as in just now. The address of string 2 is moved to EDX register, and then it will display the string to ask the user to input the value, and then the user will write the value by call read dec, where a decimal number is read from the user into the program, and then the EAX value will be moved to side hex 2 variable. Next, move EDX offset string 3 to move. This is to move the address of string 3 to EDX, which is we want to calculate the parameter for hexagon 1. After the write string instruction, the string parameter for hexagon 1 with side equals 2 will be displayed, and then the side hex 1 variable just now input by the user will again move to EAX for the calculation later, and then write integer will show again the signed integer what user has input, Then we move the address of string 5, which is the word is, to the EDX register. Then write string is called to display the string. Next, we'll need the loop counter to help us to calculate the sum for the parameter in hexagon 1 only. So loop counter ECX is assigned with the value of 6 because hexagon has 6 regular sides, and therefore the loop counter will loop for 6 times. Then we fill the EAX register with the variable of parameter hexagon 1 with the value I input just now, which is 5. The loop will begin right now until it turns to 0. Now the EAX has 30 as the value because the value of 5 is being added for 6 times, which is 5 times 6. Here we use the loop instruction. Then we'll move the EAX variable storing the sum, which is 30 just now. Here we move again to the parameter hexagon 1 because at the end we want it to store the parameter of the hexagon 1. Then after this, the parameter hexagon 1 will now have the same value of EAX, which is 30. Then write integer instruction will display the signed integer of the sum. And then the move EDX offset string 4 here will again repeat the process for the parameter to calculate the hexagon 2 parameter. Write string instruction is executed to display the string of the line to ask the user to input. And then the value of side text 2, which I as the user entered just now, will move to the EAX register. Write integer instruction will show again the signed integer what I has input. And then we'll repeat. 6 is assigned to the ECX counter as a loop counter. Now EAX register is having the variable of parameter hexagon 2. And here the second loop will begin. So I name it with the name L2 as loop 2. And now the side text 2 is added into the EAX register with 6 times until ECX register turns to 0. In the end, we'll need to calculate the total parameter. So first, we'll move the address of string 6 assigned at the data segment above to be moved into the EDX register. Then the string the total parameter equals to will be displayed after write string instruction is executed. Then the total parameter which I assign as 0 at above initially to store the parameter is moved to the EAX register. So now EAX register will store the sum. And then add EAX parameter underscore hexagon 1. This indicates that the parameter of the hexagon 1 which calculated before this using loop concept is added to the EAX register. So now EAX register will have the value of the total parameter for parameter of hexagon 1 only. After the instruction of add EAX parameter underscore hexagon 2, the parameter of hexagon 2 is then added again to EAX register with a different value, as the value input by the user is different for every time. So at last, the sum will store in EAX register. Now we want to display it, right? So I will write the instruction call write integer. I want it to be displayed as signed integer for the sum of the total parameter for these both hexagons. Call Control F is written to enable the program to go to the next line. Same as the enter in the keyboard. Question 2. This question will require us to write a program to solve the problem of a simple multiplication process where it involves the multiplicand and the multiplier. So in the data segment, the strings to prompt the user to write the input and the variable to store the value entered by user are declared. First, debug first to show the overall process of a successful execution for this question. So now the user will ask me as a user to enter a multiplicand 1 until 9. 4 is entered for the multiplicand, and for the multiplier I will enter for 5. And the multiplication of 4 times 5, where 4 and 5 are entered by the user as the multiplicand and multiplier, and then the product is calculated and shown as 20. The address of string 1 will be moved to EDX, and then write string instruction is called to display the string 1, and then read deck is executed to ask the user to enter the value. So now EAX will have the value of 4, right? Now we have to move it to the multiplicand variable to store it. Next, move EDX offset string 2 is executed to prompt the user to enter the value of multiplier, and then write string is executed to display the line of string 2, and then read decimal will ask the user to enter another value for the multiplier. 5 is entered. And then now EAX will have the value of 5. Note that the EAX will serve as a temporary container to store the value change every time. And then this EAX value will be moved to the multiplier variable to be stored, as mentioned in the question. And then this will need to progress to the multiplication process. And then write string is instructed to call, then display the line of string multiplication, and we'll need to move the value inside the multiplicand variable to the EAX register. So now EAX register will have the value of 4, and then we'll need to display by the instruction of write that of. Then here we'll need the line of string 3, which is the symbol of multiplication, to be displayed. So we'll again execute the lines written same as the process in string 1 and string 2. Here comes the progress to show the final product of the both multiplicand and multiplier after multiplication. So now the string product address will be moved to EDX register, and then the write string instruction is executed to display the line of the string product, which I declare above. The product is, and then the multiplicand is moved to EAX register to be stored in the EAX register. Then I will multiply the value in the EAX register multiplicand with the value of multiplier. After the instruction of write that is executed, the product of the multiplication is displayed, And here 20 is shown in the EAX register because the final product is stored in the EAX register. For the extra challenge in question 2, the program will ask the user, do the user want to continue the calculation or not? And then the user will need to answer yes or no. And then if yes, the program will either ask the user whether to perform multiplication or division. And if no, the program will pop up the instruction of thank you, and then we'll exit the program. So I've made some changes in this program to run the extra challenge requirement. The highlighted lines are added as the data segment. And then started from here, move EDX offset string continue. This one is to move the address of string continue into the EDX register. Then write string instruction will ask the program to display the line. And then this one EDX register will need to store the address of the buffer one, which is the variable, because this one user need to enter, right? So after that, ECX register is to store the size and to specify the maximum characters. And then read string instruction is executed to read the user input. And then write string is to display the user input. Then this instruction jump read will jump to the instruction of read. After jump to read instruction, read that is called to read the value, because I assign 1 as yes and 2 as no. And then JNC Y input, if the condition is met, means that if the user enters either 1 or 2, it will jump to Y input. Here I assign Y num as the variable to store the value input by the user just now. So I will compare Y num with the number of 1. If yes, it will go to this yes segment. In yes segment, the string yes instruction, the address string yes will be moved to EDX register. Then the string yes line will be displayed after write string instruction is executed. String yes is to ask the user perform multiplication or division. Then move EDX offset buffer 2. Here buffer 2 will need the user to enter the answer, whether multiplication or division. And then ECX is to store the size of the string. And then read string. Read string will read the string from the user. That means read the input from the user. And then it will end the program. If no, it will move to string no line. That means we'll ask the program to show the line of thank you. So string no is put at the bottom of JES instruction. Write string execution will display the line of string no, which is thank you. And then it will exit the program execution. Question 3. In question 3, I will need to write a program that interactively prompt the user to input 6 integers, and that 6 integers will be stored in an array called hello. And then the values in the array odd will be calculated and stored in the variable of total odd, and the values in the even array will be stored in the variable of total even. And lastly, for the extra challenge, the total even values in the array and the total odd array values will be calculated and sum out and be stored in the total odd variable. So in the data segment, all the string and the data variables such as total even, total odd, and total odd are declared. In the code segment, this highlighted part will be used throughout almost this program execution. The concept is to prompt the user to input 6 values. So this highlighted part lines will be repeated for 6 times. Only the difference is the hello array value, the position will be changed. First, move the address of string 1, which is enter the integer, into EDX register. Then write string instruction is to display the string 1 line, and then print integer is to prompt the user to input for the hello array, the first integer, and then we'll move the EAX value storing the user input into the first position in the array. And notice that in this array, each integer is added to the next by adding the array value by 4. So for the second integer, the array value will be hello plus 4. The third will be hello plus 8. The fourth will be hello plus 12. The fifth will be hello plus 15. And the last, the sixth number, will be hello plus 20. And here comes the loop part to do the addition for the values in the odd array and even array. Here is the overall picture after the program is executed. So I will enter each value. Notice that the odd array is the first, the third, and the fifth. So 1 plus 3 plus 5 will be 9. And the same concept to the total even variable, 2 plus 4 plus 6 will be 12. And then the total for this total odd and total even is positive 21. And according to the question, it will be needed to display at the center of the screen. First, we'll need the EDI register as a pointer for the destination. So we'll move the hello array address into EDI register. And then I will make the EAX register as the container to be used in the loop. So I will clear it. So I put 0 into the EAX register. Then ECX register as the loop counter. So I put 3 inside the ECX register. So loop 1 will start here. Add EAX array EDI. I will add the value of hello array, that means the position, into the EAX. So here I will do for the first array, first even. So here I will do the first odd array. And then add EDI 8 is to add EDI address by 8. Here will go to the third odd array value, and then it will keep looping and keep doing the addition until ECX turns to 0. So this total odd value in the EAX will be moved to the total odd variable. And same goes to the next. Move EDI offset hello plus 4. Here we will do the conditions for the loop 2 to calculate the total even array values in the even array. And here, move EDX string 2 This one, we want to know the total odd value. So we'll move the string to address into the EDX, and then the string of total odd will be displayed. And then write that instruction will ask the system to display the value we calculated just now. And then for the string 4, this one is for the extra challenge. We need to calculate the sum for the total odd and total even. So the difference is here. I will need to move the total odd value stored just now to the EAX register as a container, and then I will add total even value to the EAX register. So now EAX register will have the sum. And lastly, I will move the sum in the EAX register to the total odd variable. And then write in instruction is to display the sum of count, is to display the sum of total odd and total even.